Hey everyone, so today we're going to be buying and selling stocks. We're going to be using the EPI Judge to test our solution for this question, which is from the book Elements of Programming Interviews in Python. And this is one of the questions in the first section. It reads, so given a list of stock prices, return the maximum profit for buying and selling a stock. And you can only buy and sell a stock before selling it. And you can make a maximum of one set of trades. So there are some other questions that follow up to this, buy and sell a stock twice, buy and sell a stock with a timeout, buy and sell a stock K times. And this is somewhat of a basic version of that problem to start with. And we'll probably be doing follow-up videos with the more difficult versions of the problems. So for example, if we have a list saying 1, 1, 2, 7, 2, 3, 1, then we would be able to buy the stock at 1 and then sell it at 7 for a total profit of 6. If we have 2, 3, 1, 4, 1, 4, 3, 5, 1, then we buy it at 1, sell it at 5 for a profit of 4. And then if we have a list that is just decrementing, so 3, 2, 1, then we simply don't make any trades and we end up with a profit of 0. So what would be a quick brute force solution for this? I guess we could just iterate over every entry of the array, and then you can say, okay, if we buy it at this spot, then how much could we sell it for? And then just check every other position. And this would of course be O of n squared time complexity, because we would be checking over every element for every element. So the way we would do this, we would say res equals 0. We would go, for I in range length of prices, and we would subtract 1 because we don't want to check the last value, because there's no point buying the last stock. Then we would loop over j, and j is going to be the index for selling the stock. We're going to say I plus 1 because we can only sell it after we buy. And we're going to say len prices. So here we're going to say buy at prices I, sell at prices j. And then what's going to be the profit there? Well, the profit's going to be prices j minus prices I. And we want to update our result if and only if this difference is better than whatever difference we found before. So we're going to say res equals max of res and this difference. And this is a very simple solution here. We're just looping over every element twice and checking what the profit would be. So let's test out the solution. And we're passing all our test cases, so our logic is correct. However, as you can see here, we're stuck on some of these last two cases where we're just not quick enough. So at some point the input becomes too long, and because of the fact that we're looping over every single element, we're losing quite a bit of time. So let's see how we could improve on this. I mean, running through this example, we have 1, 1, 2, 7, 2, 3, 1. So picture this. I mean, we have a stock at 1. That's the lowest price that we've seen so far. We can buy it at 1. We can take a look at the next element. We can say, okay, well, if we sell it at 1, we would get a profit of 1 minus 1. That would be 0. So our best profit is 0. And the lowest price that we could have ever bought it for was 1. So we're just going to remember that. We're going to remember we had a 1, and we're going to forget about everything else. We're going to move on to the next value. We're going to see, okay, we have a 2 here. So if we sell it at 2, we're going to get a profit of 1. So if we have a profit of 1, then we can keep that profit. But we're still gonna see that buying it at 2, there's no point of ever buying it at 2 if we could have bought it at 1. We want to buy low and sell high, not vice versa. So now when we get to the 7 here, we can say, okay, we can buy it, we can buy it at the 1, we can sell it at 7 to get a profit of 6. After we've sold it, we can forget about the 7 because we're never going to buy it at 7. So now we're going to check the 2, we're going to check the 3, we're going to check the 1, and none of those are going to give us a better profit than this initial 1 and 7. So we can return 6. So what we see is we can do this in one pass just by keeping track of 2 things. We need to keep track of the result, which is our max profit, and we need to keep track of min price, right? Because if we can buy it at some minimum price, then we're never going to buy it for higher, right? So when we have this 1 here, we're never going to buy it for 2, we're never going to buy it for 7. You know, in the second example, if we buy it at 2, then later we might see a 1. So if we see this 1, we can update our min price to 1. And then later see, well, 4, we can forget about the 4. 3, we can forget about the 3. 5, we can get a profit of 4 here. But each time we're going to be comparing it only to the 1. So instead of checking every single buy, we're simply going to keep track of the minimum price and then compare it with the max profit. So how would this look? So let's say max profit equals 0. Let's say min price equals 0 as well to start. Actually, let's start with min price being max. So float inf, we're just going to start with min price being infinity, and we're going to loop over the prices. So we're going to say 4p in prices. We're going to say what's the max profit? The max profit is going to be either whatever the maximum profit was for the subarray that came before, or it's going to be the max of buying it at the minimum price and then selling it for p. So the max profit is going to be p minus min price, or it's going to be max profit. So we're going to take the maximum of these 2 values. And then we're going to have to check, well, should we update min price? So have we seen a price that is better, or are we just going to keep whatever price we had before? So we're going to take the minimum of p, which is our current price. We're going to see if p is better than the price that came before. And if it isn't, we're just going to keep min price as it is. And then after that, after we've looped over every single entry, we simply return max profit. And then if we run this, now we pass those last 2 test cases no problem. We finish in 18 milliseconds, which is sufficiently fast. And we've passed all our test cases, which is the important part. Now, there are follow-up questions here. You know, how do you do this if you need to do it twice? How do you do this if you have a timeout? How do you do this if you have, you know, K purchases? How do you do it if you have an infinite number of purchases? So these are all very, very interesting questions that we will get into future videos. But for now, if you enjoyed this, then please like, comment, and subscribe. And if you're interested in getting personalized tutoring or mock interviews, then click on the link in the description. Anyways, until next time, have a good day.